In this video, we're going to go into a bit more detail about the stack abstract data type and how it can be implemented. So here's the abstract data type for a stack. So we have member functions for push, so that adds an element to the stack. Top, that returns the most recently added element to the stack that hasn't already been removed from the stack. Pop, that removes the top element of the stack. And size just returns the number of elements in the stack. So let me illustrate these functions now. So generally we picture a stack as growing upwards. So when we add an element to the stack, we kind of put it on top of the stack. So in this example here, we can start with an empty stack. Then if we were to push an opening paren, then we get the picture on the left there. And if we were then to push the opening curly brace, that would go on top of the opening paren. And then if we were to push another opening curly brace, that again goes on top. So the top operation, when we picture a stack in this way as growing upwards, it just returns the top element. So top on this example would return the curly brace, and on this example would return the curly bracket. Pop removes the top element of the stack. So if we call pop on this example, that would remove the curly brace at the top of the stack on the left. And on this example, pop removes the opening bracket on the stack on the left. So in general, a stack has last in, first out behavior. So when we call pop, it's going to remove the most recently added element to the stack. So for the names of our functions in this abstract data type, we've used the names used by the standard library implementation of stack. So here's the page from CPP reference about a stack, and we can see the member functions, and you see the ones that I've talked about, top, push, and pop. So those are the main functions of a stack. Okay, now let's talk about how you can implement a stack. So the abstract data type of a stack is actually a subset of the abstract data type for a resizable array. And if we turn a stack on its side, we can recognize the operations of push and pop as just being the same as pushback and popback on a resizable array. And we can also implement top with a resizable array because we can just get an element by its index, so we can just get the element with index size -1. Okay, so the abstract data type of a stack is actually a subset of that of a resizable array. So we can implement a stack with a vector or even a list or a deck. And the standard library implementation of a stack is what's called a container adapter. So it's really just a thin wrapper around another container. And the default container to use in the standard library is a deck. But if you want to use a list or a vector, you can specify that as well. Okay, so let's talk about actually using a stack in practice. So the downside of using a stack is that we cannot iterate through the items in a stack without changing the stack. So in order to see what's in our stack at a given time, we'd have to pop the elements off in the process. So that makes debugging a bit annoying, because if you want to see what's going wrong, see what's actually inside your stack, then you're going to have to change the stack in order to do that. And now also, with a stack, we give up operations compared to, say, a vector. And usually when you compare abstract data types, if you give up some functions, then you might expect a performance benefit in the functions that you keep. But that's not the case in a stack. So in a stack, basically, you're giving up functions compared to a resizable array, but you're actually not gaining any performance benefits in exchange. So I think really the only advantage to using a stack instead of, say, just using a vector is just to point out to readers of your code that, hey, I really only need this subset of operations provided by a stack here. But usually when I'm coding myself, I'll just use a standard vector instead. It's just easier, it makes it easier to debug, and really a stack is such a thin wrapper over something like a standard vector. I don't think it really makes that much of a difference in actually writing the code.